This proportion video will cover week 6, numbers 11 to 15 in your booklet. Number 11 states, on an architect's blueprint, 1 inch corresponds to 12 feet. If the exterior wall is 68 feet long, find how long the blueprint measurements should be. Write the answer as a mixed number if necessary. So you need to take your information and organize it into a pattern. The question you should ask yourself is, if the length of a line on the blueprint goes up, would you expect the real life measurement to also increase? And the answer is yes, which makes this a direct proportion, which means we're going to write it as a direct proportion. 1 inch on the top over 12 feet on the bottom. That's a direct proportion. In the other half, we're going to write down what we know. In real life, 68 feet would go on the bottom. How many inches would the blueprint actually be? We're going to do the same procedure that we always do, which is cross multiply and divide. Circle the number across from the x and cross multiply. So x is going to equal 68 times 1 divided by 12. So x is going to equal 68 over 12. If we take that number and we break it down into a decimal, we would get 5.6 repeating. And 5.6 is 5 and 6 over 9, which is 5 and 2/3. So 5 2/3 inches would be the length of that wall on the blueprint. Question 12 says, a tree 40 feet high casts a shadow 30 feet long. At the same time, a building casts a shadow which is 51 feet long. How tall is the building? So you get your tree casting a shadow. You've got your building casting a shadow. One would expect the higher the object, the longer the shadow, which makes this a direct proportion. We're going to compare height to shadow. A little legend to yourself. So the height of 40 feet and the shadow is 30 feet. That's for the tree. For the building, which is 51 feet long, the shadow is rather, how tall is the building? So the height of the building is your unknown, which is your x. So to solve for this one, you're going to cross multiply and divide by 30. The height of the building then is going to equal the product of 40 times 51 divided by 30, and the top number, which is the height of the building, is going to be 68 feet, which you should anticipate as being reasonable because for a shadow of 30 feet with a tree, the height was 40, which is larger, so 51, answer 68 is reasonable. Question 13. On an average, 9 workers can deliver 3,000 telephone books door to door in 6 hours. How many workers will be required to do the same job in 4.5 hours? So essentially, if the number of workers was to change, in this case, we don't know how it would change, but the time is going down. If you want to do the same job in less time, you're going to have more workers, which should tell you that this is an inverse proportion, which means it's done slightly differently. We're going to compare workers to time. So we're told 9 workers can do the job in 6 hours. 9 workers. I set it up exactly the same way that I set it the previous questions, clearly the answer is not going to give us what I need, but I'm going to set it up first like this anyway, 4.5 hours. If I solved it by cross-multiplying and dividing this way, I would not get an answer that would reflect the reality. So you need to remember what we learned together in class. You have to switch the denominators in order for the inverse proportion to give you the proper answer. So 9 out of 4.5 is going to equal how much out of 6? When you cross multiply and divide with this setup, you're going to get an answer of 12. And 12 is the number of workers. So let's read the question again. If you went from 9 workers up to 12 workers, you could get the job done faster. That makes sense. The way it's set up in our second fraction, which I'll put a box around, you can see the numerator is exactly double, so it makes sense that the second fraction should be also double, which is 12 workers. Number 14 says, it's recommended there be 9.8 square feet of space for every student in the class. Find the minimum floor space that 31 students would require. So if you had more students, would you need more space? And the answer is yes, which makes this a simple, direct proportion. Therefore, we're going to compare students to space, which is going to be in square feet. So students to square feet. Start up our first half, which is kind of like your little law, which says 1 student requires 9.8 square feet. So how many square feet would you need for 31 students? So cross multiplying and dividing by 1, you're going to take 31 and multiply it by 9.8, and you're going to get 303.8 square feet. If the students go up, the space should also go up. Okay, question 15 says an oil burner heats air, then a fan blows it straight forward. As the distance from the burner increases, the temperature drops proportionally. When the distance is 2 meters, the temperature is 24 degrees Celsius. Find what the temperature will be at 3 meters to the nearest tenth of a degree. So if the distance goes up, the temperature goes down, which makes it an inverse proportion. We are comparing temperature to distance. With an inverse proportion, we have to do an extra step. Temperature, 24 degrees Celsius. Distance, 2 meters. If the distance goes 3 meters, the temperature, so the distance goes up, the temperature would obviously go down. In order to make that work, we have to do an inverse flip on part of our setup. We choose to use the bottom. So 24 over x is going to equal, 24 over 3 would equal x over 2. Switch my denominators. So mathematically, we're going to multiply 24 times 2 and divide it by 3. So 48 divided by 3 is going to give you 16, and that was a temperature, so 16 degrees Celsius. The temperature went down because the distance went up. And that's an example of an inverse proportion. Remember, the inverse proportions are set up the same way, but you have to add that switch step to make the math work.